Good day, engineers. I am your Tito engineer, and today we will discuss the part 3 of our buoyancy problems series. Problem number 3. Ship having a DISP basement of 24,000 metric tons in draft of 10.4 m in ocean with a specific gravity of 1.03 enters a harbor of fresh water with a specific gravity of 1. If the horizontal section of the ship at the waterline is 3,000 square meters, what depth of fresh water is required to float the ship? For our illustration, we actually have two situations. First is when the ship is at the ocean, and the second one is when ship is at the fresh water. By simple logic, when we are swimming in ocean which is salty, our body tends to float easier, therefore draft will be lesser. When we go for a swimming to a fresh water, we tend to sink easier, therefore the draft will become greater. The reason behind this one is that ocean has a higher density than freshwater. As we can recall, buoyant force is an upward force that is equal to unit weight times volume. Therefore buoyant force is directly proportional to the unit weight. As the unit weight increases, the buoyant force also increases, and it will push the object slightly higher than that of fresh water. Continuing, for our solution to the problem number 3. If we can recall our formula for buoyant force is equal to unit weight of fluid multiplied by the volume displaced. We can also recall the density is equal to mass over volume. Solving for volume, we get volume is equal to mass divided by density. Next, we will solve for the volume displaced by the ship at ocean and also at the fresh water. We also will convert the given ship displacement of 24,000 metric tons to 24,000,000 kilogram for uniformity of units. At the ocean, volume displaced is equal to mass divided by density, or 24 million divided by 1,000 times 1.03. Volume displaced is equal to 300.97 cubic meters. Next, at the freshwater, volume displaced is equal to mass divided by density, or 24 million divided by 1,000 times 1. Volume displaced is equal to 24,000 cubic meters. Next, we need to determine the change in volume displaced from ocean to fresh water. That is, 24,000 cubic meters minus 300.97 cubic meters equal to 699.03 cubic meters. Now from basic solid mensuration, we can recall that volume is equal to area times height. Or, change in volume is equal to area times change in height. Substituting it to our solution, we get delta V, or change in volume displaced, is equal to area times delta H, or change in draft. Delta H is now equal to delta V divided by area. Now from the problem, we were given that the area is equal to 3,000 square meters. Substituting it to our working equation, we got change in draft is equal to 699.03 cubic meters divided by 300 square meters. Change in draft is therefore equal to 0.233 meter. Note that this is still not our final answer, since we are asked about the depth of fresh water required to float the ship. We also have to take note that we are given with the drafted ship at the ocean equal to 10.4 m. Again, by logic, the drafted fresh water is greater than that of the fresh water, therefore we need to add the drafted ocean to the change in draft in order to obtain the depth of fresh water required to float the ship. It should not be subtracted, since by doing so, it will make the draft lesser than the draft at the ocean that is denser, so it is not possible. Finally, the depth of fresh water required to float the ship is therefore equal to 10.633 meters. Part 4 for buoyancy problems will be posted next. Stay tuned. Like, share and subscribe to your Tito Engineer for more problems for civil engineer and master plumber board exam. Thank you.